Welcome back, everyone, and today we're here with the Sioux Falls physics teachers looking at a problem on horizontal projectiles.
Before we start this, we should do a couple of things. One is to draw a diagram of what this is going to look like. So if it's launched horizontally, then that means that it's coming off of the top of a surface. So initially it has velocity only in the x direction. So when it says it's launched horizontally with a velocity of 6 meters per second, that is our v sub x. The second thing we should probably note is that we're going to ignore air resistance as usual, and also that realistically 2 seconds would be a really long time for something to be in the air. So in order for that to happen, we'd be looking at an exceptionally tall building for this projectile to be able to fall that long.
Okay, now let's start looking at determining what the horizontal and vertical velocities would be after 2 seconds. Let's start with the horizontal, because that's really a relatively easy calculation here. We know we start out with a horizontal velocity of 6 meters per second, and since we're neglecting air resistance, that velocity is going to continue for the 2 seconds. So to figure out the vertical or the horizontal velocity, it's still 6 meters per second. That hasn't changed. So we know that our v sub x after the 2 seconds would still be 6 meters per second. Nothing is going to change that. Now, for the vertical velocity, what we'll call v sub y, that is how fast this projectile is going to start falling downward as it goes. Gravity will be acting upon that. To calculate that v sub y, we'll use the following equation. The v sub y, which will be the final velocity at the end of 2 seconds, is equal to our initial velocity plus acceleration times time. Filling in those values, the initial velocity in the vertical direction was 0. Okay? It was not falling down when it was initially shot, plus acceleration should be a negative value because we're going down, so negative 10 meters per second squared, and we are doing that for a time of 2 seconds. So this velocity in the y direction will end up becoming negative 20 meters per second. Negative because we are going in a downward direction.
Okay. That means we're ready to take a look at the horizontal and vertical displacements. We already have our full displacement equation here, and the first thing we need to do is figure out what would be important in the x direction. So notice that first of all, we want to know the horizontal displacement after 2 seconds. Again, we don't need to worry about any initial distance, but we do have an initial velocity. However, in the horizontal direction, we do not have any acceleration. So all we're left with then is initial velocity times time. Our initial velocity is 6 meters per second. Our time is 2 seconds. And so in the x direction, after 2 seconds, it has traveled a total of 12 meters. Okay, now we'll use the same basic equation in the y direction, and again we want to take a look at just the parts in the vertical direction. We don't need to worry about that initial distance. We also do not have any initial velocity in the y direction. So we are just left with the last part of the equation this time, 1/2 at squared. So in the y direction, we would have 1/2 times negative 10 for gravity, that's our acceleration, times our time of 2 seconds squared. And if we take a look at this, notice that we're going to end up with a negative number, and we will have a negative 20 meters. The negative here just indicates that in the y direction, our ending spot is below where we started.
at a problem today using another example of a final velocity in a horizontal projectile. In this case, as you can see from the picture, we've got a baseball player throwing a ball at 8 meters per second horizontally. And he's throwing the ball from a height of 1.5 meters. The question for the day is simple. Baseball is thrown at a horizontal velocity of 8 meters per second from a height of 1.5 meters. Determine the final velocity of the ball. Now this would be easy in space if you think about it. The ball would just go in a straight line. But we're dealing with gravity on Earth, so we have to deal with this vertical component. Gravity is going to cause the ball to accelerate and to actually move in an arc. What we're looking for is what this velocity is just as it hits the ground. This is our final velocity. And if you notice, that velocity has both a horizontal component and a vertical component. So we need to find both of those before we can find that final velocity. So let's start with the easy part. Turns out we know the horizontal. The reason we know the horizontal component is nothing's affecting it in this direction. So our final horizontal velocity must be the same that it starts with, or 8 meters per second. That part was easy. Let's now find the initial vertical component. Well, that's easy too, because that initial vertical component is going to be 0. But the thing we need to do is find out how long it's in the air before we can find the final velocity in the y direction. To do that, we need to recognize the ball is essentially falling. And we can use the simple equation d equals 1/2 at squared. Our distance is 1.5 meters. Our acceleration is gravity, which is 9.8 meters per second squared. The time is what we're solving for. Now, a couple quick notes. It turns out that the distance is actually negative 1.5 meters because acceleration is negative. They're both going down. But what's going to happen is both those negatives are going to cancel. But our initial height is up here, and we're going down 1.5 meters, and that's what makes it negative. If we solve for this time, we're going to get a time that is 0.55 seconds. Now we can use this time. We know the initial velocity in the y direction. We know the time is in the air. We know the acceleration. Let's go to a different kinematic equation. In this case, the equation that we're going to go to is our final velocity in the y is going to be equal to our initial velocity in the y plus at, acceleration times time. Well, we already know our initial velocity in the y is 0. We also know that the acceleration acting on it is minus 9.8. And we know the time, because the time is the thing that's the same in both the x and the y, is 0.55 seconds. Well, at this point, it's just an algebra problem. When we solve for this, we get minus 5.4 meters per second. Now that we have these two velocities, we need to put them together. To do that, we should probably draw a little picture. So, what we have here is an initial velocity in the x direction, and actually it's our final velocity also. So let's put that down, Vx final, which is going to be 8 meters per second. And now from the head of that, we're going to put our vertical, our y velocity. And because it's negative, it's going to go down 5.4 meters per second. And in reality, the h should be a little bit longer because it's a greater velocity. Our resultant is going to be our answer. And our resultant goes from where we started to where we finish. By using Pythagorean theorem, we can solve for the magnitude of this. To do that, we simply do v final, this is my total, equals v x final squared plus vy final squared. So I've got 8 meters per second squared plus 5.4 meters per second squared. Whether it's negative or positive doesn't matter, because the negative will square, we'll still get a positive answer. If we solve for this by squaring those, adding together, and then taking the square root, we're going to get an answer of 9.65 meters per second. But it's a vector. We need to know the angle also. So we need to know this angle. To do that, we can now recognize that we have an opposite side and an adjacent side. That's tangent. So let's go ahead and solve for that angle. We've got the actual magnitude already. The angle will simply be tangent theta equals my opposite. My opposite will be 5.4 divided by my adjacent, which is 8. When we solve for that angle, we're going to get 34 degrees below the positive x-axis. If we were to measure this from the x-axis, we actually have to go all the way around in this direction, and we would simply take the 34 from 360, and we would add an angle of 326 degrees from the positive x-axis using math conventions. So our final answer in this case will be 9.65 meters per second, and we can use either angle as our answer for the direction.
Mr. Newitt is back.
And Mrs. Newitt.
We're going to look at today some initial velocity of a horizontal projectile. A dart is launched horizontally from a surface that is 1.5 meters high. It lands on the floor 4 meters away. Calculate the initial velocity of the dart. First thing we want to look at is the time that this dart is in the air. We could figure that out based on some of the information we know about the vertical behavior of this dart once it is launched. Given that it is falling 1.5 meters, we have the equation for distance here, and we're going to be looking at this in the vertical component. We know the distance that this projectile falls is 1.5 meters. Okay, that is going to be equal to the initial distance, which is 0, so we don't have to worry about that. It has no initial velocity in the vertical direction, so we don't have to worry about that. And we could set that equal to 1/2 the acceleration, which is going to be due to gravity, so that's negative 10 meters per second squared times time squared. And this will allow us then to solve for time. And since this distance is going down, we need that to be in a negative value there. It's a negative 1.5 since it's going down. Let's keep that in conjunction with the gravity being negative. Solve that for t, and we get a value of t for that to be 0.55 seconds.
Okay, now that we have the time that that projectile is in the air, we can use that to figure out the initial velocity. And notice that it was launched horizontally. So when it says calculate the initial velocity, here we mean Vx. So we're going to look at the behavior in the x direction. If we go back to our full distance equation, notice that we can get rid of initial distance. We do have an initial velocity, but in the x direction we would not have any acceleration. So our equation in the x direction can be written like this. We are given the horizontal distance as 4 meters. Our velocity is unknown, and we now have that time of 0.55 seconds. If we plug that in and solve for our unknown, we end up with a total of 7.3 meters per second.